start in the there are a lot of already training sessions have taken place on compressor system. They have covered most of the things about selection of compressors, types of compressors, piping, air leaks, etc. So in this presentation, I would like to give certain inputs how to save conserve energy in compressor system. I achieved close to 50 to 60% in some industries by various measures in leading industries in compressor system alone. We cannot achieve that much savings in any other utility, either pumping or steam or electrical. Achieving 10 to 15% is a very good achievement. But compressor system, there is always potential to achieve more than 50%. We can reduce number of compressors operating and throw away some compressors. It is possible. Okay. There is always a minimum of 15 to 20%, even if it is a new installation or already savings have been achieved. It is possible either through operational changes or retrofitting or change of equipments. If you take about compressor system, we should not see only as a air compressor alone. So we have to see in total, starting from compressor up to the application. In between, you have prime mover, air dryer, filters, piping, control valves, etc. Yeah. So you have to see in total. You cannot see in isolation in compressor system. So if you see in isolation, you will get the savings of 3 or 5% only. But if you see in total, if you properly audit or investigate in total system, you can achieve greater results. So I'm calling INCON opportunities in compressor system. So I will quickly go through what are the opportunities available, even though it is covered by other speakers. Then I'll come to some special projects. The compressor system energy conservation you can divide into 3: savings opportunities by only operational changes. Second one, opportunities by retrofitting. Third one, opportunities by replacement or installing new equipments. So what are the opportunities by operational changes? So operating at optimum air pressure. You operate the compressors only at required air pressure. Often I find most of industries, they operate at very, very high pressure than required. So you have to give minimum allowance or a cushion in the compressor operating pressure setting. So you have to investigate in total, starting from application reverse, you have to see. You cannot just reduce the pressure at the compressor and achieve the savings. But you have to see each and every application, what the setting, every application, it will have its own pressure regulators. Some regulators, they would have kept at 4.5, some at 5.5, some at 7 kg. So you have to study in total, then only you can optimize air pressure. So once you optimize air pressure, you will get double savings. One at compressor power. Second, your overall consumption also will come down. If you operate lower pressure, your consumption will come down drastically. So there is a potential. If you reduce air pressure setting by 1 kg, you can achieve 6 plus 6, 12% minimum of savings you can achieve. And directly. Indirectly, it will reduce wear and tear, temperature rise, and again maintenance cost reduction, and all will come. Then maintaining compressor and accessories performance. You have to check performance of compressors always. You have to check for specific power consumption, or you have to check the parameters like DP across the era. Nowadays, I'm just concentrating on screw because majority of industries have switched over to screw compressors. Reciprocating compressors are only very limited, only for high pressure and gas applications. So I'm concentrating on more on screw compressors. Of course, if anybody interested on reciprocating compressors, that also I can cover, because my all other earlier presentations were for reciprocating compressors only. Of late, I was switched over to, because many clients, almost more than 90%, they switched over to screw compressors for some reason or other. So maintaining compressors performance is the main key. You have to check what is the temperature rise, what is the air oil pressure, air oil pressure drop across air oil separator, then cooling system, and accessories like cooler, performance of coolers, and air dryer performance, then oil filter performance, non-return valve performance. So each and every accessory, it plays its own role. So only if you maintain properly in total, you can achieve good performance for the total system. Then eliminating leakage losses. Leakage losses is the any auditor, they will not miss out the leakage losses, because air compressor main losses are leakage thing. So you have to periodically check leakage losses. See, I have been working with certain automobile industries. We used to check shift-wise. When we used to get paid on the overall leakage reduction. Base level was maintained before signing the order. Then we will every week during lunch hours or dinner hours, we will check for leaks, how much ASC capacity is thrown out for air leaks. That will be recorded. When certain industries, they are doing it actually to that extent. Remember, Hyundai and other car industries like kWh per car, now they started recording CFM per car and water liters per car, fuel per car. They are recording, they are monitoring. So that since power cost is very high, compressor cost is very high, they started monitoring and leakage losses. So I'll come back out to RS leaks later. Okay. Then avoiding misuse of compressor. Throughout the plant, there will be a lot of points where air will be used for cleaning. In summer, people used to keep hoses open. I've seen in many industries. They will keep fans will be there. Still, they will keep one hose open for cooling purpose, and compressors are used for agitation purpose. So, a lot of misuse of air. High pressure air is used for low pressure applications. Those things can be avoided. So this will give a lot of savings actually. Then periodic servicing of pneumatic instruments. This is a very, very important. People check the performance of compressor, accessories, leakages, but nobody does any structured servicing of pneumatic instruments. What are the pneumatic instruments? Solenoid valves, your cylinders, actuators, those things have to be serviced periodically. You have to replace kits, sealing kits, because major air consumption for in the any compressor system is for pneumatic instruments. Some application process also there, but pneumatic instruments, there will be air passing. In solenoid valve, o-ring may have gone, and piston ring would have worn out in the cylinders, actuators. So those things you have to have structured program to maintain. You should have replaced a new set of solenoid valves, replace in certain frequency, and keep the instruments serviced. Okay. Here, investment for these operational changes is very nil or negligible, very negligible. It can be managed by your revenue thing. No capital investment is required. Next one, optimization by retrofit. Retrofit again, periodical air leak test, identification, tagging, arresting all leaks. So why it is retrofit? I put leaks. Certain thing instruments we can arrest immediately. Certain things, piping needs modification. You would have put union joints. It may be leaking. Some corridor pipe may be leaking, so the retrofit is required. Then retrofitting piping with lowest possible pressure drop and leak-free system. So you have to check for pressure drop always. So pressure drop is more. Even we can design with the 0.5 kg pressure drop for a 1 kilometer of piping. We can design. We have designed properly, we can design. So in any factory, pressure drop should not be more than 0.5 kg from compressor to last point. If pressure drop is more than 0.5 kg, you have to see the system. Filters may be undersized, or pipe size may be less. So some union joints may be leaking, or aluminum. Nowadays, people have gone for aluminum joints, aluminum piping. But over the period, the seal rings given for the aluminum started leaking, gets hardened. So there you have to concentrate. So it's retrofit work actually. Then it involves certain investment. Servicing of pneumatic instruments also, cylinders also, and this will reduce overall consumption. If you do periodical servicing, it will reduce overall consumption. Then provision of isolation walls for individual department. Most of the factories, they are not running all the department or production halls 24/7. Some operates only for one shift, some operates for two shifts, some operates for all the three shifts. So if you have isolation, I prefer isolation, automatic isolation also. Whenever they switch off the machines, air supply should be cut off. Or department, they should cut off air supply, which is not happening nowadays, but it should happen. Because whatever leaks happening in this department can be totally eliminated. Then solenoid valve controls linked to operation to the individual equipments. Each equipment should have a solenoid linked valve. Whenever the machine is switched on, air will open. Otherwise, air will be cut off. This can be done. And optimizing operating pressure at all points and last at the compressor end. So install air pressure regulators if it is not there. You control the pressure, required pressure. Some may require only 4.5, some may require 6 kg, some may require 5.5. You control whatever required as specified or as the equipment runs without any problem. Then timer-based control. Again, the timer. See, during lunch hours or dinner, you can have automatic control. Automatic that will stop. You don't need to intervene at all. The reducing speed of the compressors. This is mainly for blowers and reciprocating compressors. If unload operations more, you can reduce the speed of the compressors. Solenoid link, this is repeated, sorry. Then using transvector nozzles for blowing and cleaning applications. Transvector nozzles are there, which magnifies the airflow using compressed air as motive pressure, and it takes or inhales atmospheric pressure and mixes, delivers at low pressure. Your capacity will enhance actually. For example, cleaning application, certainly you can go for transvector nozzles. You can cut down your consumption by more than 60% or 70, cut down by 70% by using transvector nozzles. Then waste heat recovery from compressor. There's a tremendous amount of heat available in the compressor. Air compressor, almost more than 90% of the energy is spent for heat. It is dissipated as heat. So this heat can be converted as a useful energy wherever your plant requires. I think more than 80% of the plant, they require either hot water or boiler feed water or process requirement for heat treatment things. In fact, I have stopped some hot water boilers by recovering heat recovery and given hot water to the boiler feed water pumps. So many applications are there. Then space heating. Places like North India, during winter, they need hot air. So there we can take this hot air from compressor for space heating. So that potential is always available in the compressors. Okay. Then replacing with the no loss drain traps. You see, majority of the customers or clients, they opt for timer based auto electronic traps. These traps doesn't know whether moisture is there or not. It will keep on draining at preset frequency or preset timings. So mostly air will be drained. It's a costly air is getting drained. There you can think of either no loss type trap, or I will give one more option. I'm coming to that presentation separately. Then pressure regulators at all points. Each and every application, and that's what I mentioned earlier, it requires its own pressure and flow. So you have to study the pattern and control the pressure accordingly. Higher the pressure, again, higher your consumptions will be more. Sometimes high pressure damages the equipment also. Then inlet air cooling. See, by cooling the compressor room by 1 degree, you can save 3% of the energy. Sorry, 3 degree cooling will result in 1% of savings. So instead of ambient 37, if ambient is conditions of 40 degree, you lose 1% energy. So you can think of inlet air cooling or keep the room cool by smart modification of compressor piping or the ducting of hot air outside. So these are the options available. Then replacing compressed air with other equipments. So you have to question why compressor is required for any application. Why not electrical? There are a lot of applications where you can replace with the electrical energy or some other energy or some other equipment like low pressure blowers or low pressure compressors. So this potential is always available. So in this opportunities, certain opportunity is negligible, then certain opportunity nominal investment is required. Okay. Then opportunities by installing new equipment or capex items. So installing variable speed retrofit or installing variable speed control for the compressors. Then installing air demand controllers. I mean, some suppliers, they supply demand side controllers. So they will install in between compressor and the air receiver. So they will control they'll have two receivers, one high pressure receiver and one low pressure receivers. It will optimize the airflow at airflow with the minimum band. There are savings, but not so attractive. But with the VFD compressors, these demand controllers can be eliminated. But the suppliers somehow they show the savings before leak arresting. After leak arresting, they can show the same savings. People like Godrej and other things, they are doing it actually. Replacing with the energy efficient air dryers. Air dryer is the again neglected equipment. Client they don't intervene at all. Whatever suppliers they give, they are using it actually. So dryers should be designed properly for the operating pressure, not for the highest pressure of the compressor. It is vice versa. Compressor can be designed or receiver can be designed for high pressure, but dryer should be designed for low pressure operation because pressure drop plays vital role in the compressor system. If dryer is designed for 9 kg pressure, and if you are operating at the 7 kg pressure, you will end up with the high pressure drop, and you lose permanently some energy. So suppliers they don't concentrate on this. Only vendors have to take care of this. Actually, I mean clients have to study. Then a replacement with the energy efficient compressors. This potential is always available. And this again, I have my own opinion. When any equipment for that matter, not only compressor, always efficiency doesn't matter. Sometimes inefficiency also will save power. in a lot of equipments. By replacing with the lower size innovation equipment, you will save power. So you have to study properly for your application, for your capacity, for your pressure, what is the best suited equipment. It may be inefficient little bit, volumetric efficiency is less, but your power consumption will be low. So you have to select suitably, very smartly. So vendor or customer engineers can do this. Suppliers, they will not do it actually. It is very painful that suppliers, they dump their products to the any factory. Whatever available with them, model or whatever package they dump. They don't allow the clients to choose their application or their choice. But it is available. After my end of my presentation, again I'll come back to this point. Actually, I was in the compressor industry. I was on the other side of the table, and now I am shifted to other side. I mean, I became a consultant. So but I behaved both ways. I mean, I say consultant also always. Sometimes I got penalized because my order value will go down. So when I teach the client, my order will go down. So I got penalized. But I was never bothered. But I got benefited also. So I win over the clients because I give them entire knowledge, total solution. So they will prefer me than other competitors. Okay, I'll give you some case study at the end of my presentation. So certain projects, say though, whatever I told you, many of the speakers or consultants or some would have made already. But certain projects which I have implemented last 30 years with thorough study, I will just show you the things. There is people, the screw compressor packages, what we get, most of the screw compressors, they're all designed for the low ambient conditions, not for tropical countries like India. But even if you take Atlas Copco or Kaiser or whoever it may be, Bogia or whatever Ingalls all right, they are all designed their equipment for their own 20-degree ambient. If you check their certificate or check the quotation properly, the 20-degree, the parameters will be only 20-degree. Whereas our ambient slowly it is going up 40 and above. Last year, place like Bhadrachalam in Andhra Pradesh, it has recorded 48 and above. It has touched 50-degree. 50-degree, these equipments will not run. I expect another 2 or 3 degree this year also, then average. Then all these equipments will run into problem. I mean, air temperature, though in other conditions like monsoon or winter, your air temperature will be 70 to 90 degree. Summer, it may touch 105 degree. You cannot run the compressors, it will trip. The failure of components will happen. Capacity will drop. At times, tanks will burst due to static current. Over the years, I have come across more than 70 to 80 blasts of the compressors. Maybe some vendors, some clients would have come across. In screw compressors, due to static current inside the compressor, at times the high air temperature, sudden blast happens. So tank air temperature will shoot up, minimum pressure will burst, oil air separator, filters will clog, oil will become a cake. Then it's a major cost for repairs actually. So to avoid that, some clients they don't operate compressors at full load. So they switch on other compressors so that this compressor load and load. So any compressor, it has to be rated to run at full load always. Compressor efficiency and specific power consumption low when compressors are operated continuous load only, not load unload. I don't prefer that. But due to this temperature rise, you are compelled to run other compressor to avoid the failure. So to overcome this, so other compressors. So I questioned him, your capacity requirement is lower than the full compressor. Why are you operating second compressor? He said same problem. So what I've done, they had a spare heat exchanger. So immediately I took the spare heat exchanger. I modified the oil circuit. I put extra heat exchanger in the circuit with temperature control. This extra heat exchanger will not run always. Whenever air oil temperature rises, the fan will run. Otherwise, it will be just only oil will pass through it. So no additional energy consumed for during normal conditions. Only during peak condition or during peak daytime, the fan will run. So you can maintain the temperature within the preset level. Required level. See, these OE suppliers will not recommend, but we can do it. We have done in many clients. I'm recommending this to many suppliers. Clients. In fact, I want all compressors to keep the heat exchangers outside, not inside the compressor room. We have to get the compressor, water cooled compressor, and they keep the closed loop cooling tower or radiator, whatever you call, outside. There's no water consumption. You can run fill with coolant like a car. You can operate. This will reduce the air oil temperature inside the room, ambient conditions in the room. Your energy consumption will come down drastically. Performance will improve. You can increase the reduce the oil changing frequency. In reverse, you can increase the oil life, and this will save a lot. In fact, you can do retrofit existing compressor also. As well as you can demand a new compressor to be like that. You order for a new compressor, you ask them, I want water cooled with the extended radiator. There are a lot of suppliers in the market for extended radiators. This will cost much less than air cooled. Your performance and your room size also will be less. You can keep the radiator outside. No water is required. For the one time filling of water is sufficient. This water, unless water is leaking, it will run for almost a year. After a year, you can just check or replace the water. Okay. So this is a good opportunity available for any vendor, any client. Then heat recovery in compressors. See, as I mentioned, 100% of the heat can be recoverable, but some thing goes away. Dry motor takes away some 5% heat. Your oil cooler 76% it is carrying, after cooler 15. So total 96, 2 or 3% heat will be dissipated in the compressor itself. That cannot be recovered. Otherwise, more than 90% of the heat, precisely 96%, but 90% heat is available. This is a golden energy actually. We are throwing away the heat within the compressor room and again increase the power. We are throwing the energy and increase the energy in the compressor room. So this is a typical thing I have done in some industries. I have put extra heat exchangers outside. It will dissipate. In the right hand side, number 4, it dissipate the heat outside. It is spent the heat. We cannot recover total heat. It will whenever the heat recovery is not used, still there will be temperature. So we have to dissipate the heat. That radiator will be there. Right hand side, number 5, it's a plate heat exchanger. Hot oil at 90 or 95, it goes up to 95 sometimes. Average 85 90 degree will be circulated. Internal temperature will be 40 45. Again, it will be cooled further. it will ambient plus 5 or 10 degree, it will rise, it will go back to the system. So by this, we are achieving 2-3 results. First, we are recovering entire heat. We can give it to process or even give it to canteen hot water. If there is no requirement for the process, you give it to canteen. Have a hot water storage, circulate the water, and give them water for dishwasher cleaning or cooking or whatever it may be. You give it to them. The process, you give it to them, or boiler feed water. So this will be a huge energy you can recover. Then by keeping radiator heat outside the room, you are keeping the compressor room very cool. So you can save on the compressor energy also. Oil replacement period will get enhanced. Your energy will increase. Your capacity will increase. When air oil temperature is less, you can check. See all. I don't know, madam. How many of the here today present? What is the attendance?
Yeah, it's around. It's 42.
But good actually. In fact, I would like more. So amongst the 40, at least I will have 20 ambassadors. So I
Yes.
work for energy efficiency throughout the world. I
Yeah.
work only for energy efficiency, not monetary. Wherever I go through, I will give all the proposals. Even if I visit one day to a client, whatever available opportunity, I list them, I will give it to them. I will not wait for my payment or anything. I don't want to be given credit for my proposals. So amongst the 40, even 20, observers or I think participants, if you achieve some percentage, I will be the happiest person. In fact,
Yeah.
I want to reduce the energy level, global energy level across the world. I'm working for it. I'll do it. Okay. So this is
Yes.
a thing. This is a good proposal available for all client. Client locations. Here there is a huge cost savings. You can improve the performance. You can improve specific power consumption will reduce. Capacity increase thing. So I will stand here. So you check for the performance test at the various air temperatures. You record. You will see in the highest temperature, your capacity will go down because due to viscosity reduction in the liquid, our lubricant, the sealing between the rotors will come down. So air passing will be there. So your capacity will reduce. So if you see day and night, always during the night time, your capacity will be more. During daytime, your capacity will be less. This is due to two reasons. Um, One, your ambient conditions are less, so density of air, you'll get more mass of air being sucked inside, you'll deliver more. Second one, air oil temperature is less in night, so your leakages back is less. So that also will thing. So as I was with the Kirloskar, we will carry out performance during only in favorable ambient conditions because it will give more capacity during night time or early morning time. Okay. One more thing I'll tell you. Whenever oil is replaced, new oil, your capacity will go down by 5 to 10%. You can check. With the old oil, because viscosity is more, sealing is will be very perfect. Your capacity will be more. So you check capacity of the compressor by either flow meter is there, you can check, or by receiver filling method you check. And after replacing the oil servicing, you check. There will be a reduction. Most of you may not be knowing. Okay. So this is the thing, observation. I also learned thing because after servicing a phone, all of a sudden some clients running more compressors. Once for AMC, people will come at a time. They will do 10 compressors servicing will go. Then you notice replacement oil, more compressors being operated. So we studied and we found out this is the reason. This is a major proposal. Other day I was telling Dr. Seduraman. Incidentally, Seduraman is available here.
No, he has not. No,
Huh?
he has. No, he has not joined.
Okay. In fact, I had a lot of discussion with you. Acha. See, most of the screw compressors available in the market, there are two types. Basically, it is a single stage or multi-stage. Then it is, oil circulated or dry screw compressor. Oil fitted rather. It's called oil fitted type compressor. In oil fitted type compressors, air and oil is mixed. Both the air is also sucked, oil is also injected, and both are compressed together and sent to air oil separator. Air oil separator, air and oil is separated. Air goes to after cooler and it goes out. Hot oil goes to oil cooler and returning back to system after air filter. And there's no pump and screw compressor. The oil flow is happening due to vacuum created, in the compressor and the pressure of the tank. The quantum of oil circulation. What is the quantum of oil circulation? See, compressors they have designed or for certain high pressure. Always compressor designed for high pressure, high capacity. But in site conditions, your pressure is not same, your capacity also not same. So why same oil flow? Why not we reduce the oil flow? So this question has been coming to me for last 10 years. 10 years before, I mean, it came. I discussed with many OEMs and things. Even our own R&D team also. Nobody openly they says yes or no, but my argument was well taken. They said yes, it can be optimized. So what I've done, step by step, I put orifice plate, and I restricted by 5%, 10%, 20%, 30%. I recorded a lot of parameters there, a lot of studies happened. So I shared with some of the suppliers. And incidentally, what happened? This is a good amount of savings, but there was negative thing also happened. Sealing due to less oil circulation, sealing has reduced. Then compression efficiency, it has gone down, but power has come down. Specific power consumption has come down. So ultimately, we are bothered about specific power consumption only, kilowatt per CFM or kilowatt per meter cube only. So we have achieved that actually. There are one or two suppliers they copied whatever I told after my intervention. They copied. They are doing it now. They are putting restrictors, flow restrictors in certain models. So this can be done actually. This will certainly it will save 3 to 5%. So for safer side, 3 to 5% is okay. Certain application can save up to 10%, but let us not go to that. Then please don't do it for the compressor under warranty, because suppliers, even though it is not that fault, they will claim that you have retrofitted the compressor, you spoil the compressor. So once a warranty is over, you can try, put a small restrictor. You start with 2% or 5%. Any proposal you do in small only. Don't do jump to the highest thing. So you restrict it, you record all the parameters, power, flow, pressure, load time, unload time, all the things you can achieve. This is 3 to 5% without any investment. All investment is only on washer, Teflon washer or some stainless steel washer. So this is the thing. So the male, how the male and female does that, how oil is injected. The purpose of oil injection, as I already told, is for lubrication, sealing between rotors, and rejection of heat. Okay. So here we can check the rejection of heat. So the temperature should not rise by putting a stick. That we have to monitor. If temperature is not rising, if power is not rising, you can go ahead. You can record the savings. Even if 1% savings, it's a good amount. Instantly, this year's Bureau of Energy Efficiency, Government of India, during Energy Conservation Day, their theme is save 1 watt. 1 watt is nothing. But if you take the population of India, everybody saves 1 watt per hour. It's a huge savings actually. Okay. So we can definitely save on this. No suppliers will support, but you can give data to them. You can question them. And in fact, I have given to data suppliers, they copied. But nowadays, none of suppliers, they don't bother about the end user comfort or end user energy conservation. They just, whatever equipment they have, they dump and they leave out. That's all. Next, typical piping in the compressor room. Generally, majority of the compressors, this has been designed by the compressor suppliers. They are all idiots actually who recommended this actually. So they install compressor dryer, dryer to oil filter, then it will go to receiver, issue to application. This is how it is there actually. Here, what happened? And there are inbuilt dryers also there. Here, if dryer is faulty, you cannot run the compressor. If compressor faulty, you cannot run the dryer. Oil filters are faulty or thing, you can total entire circuit you have to close. There will be huge pressure drop in this actually. Here, heat load on, there's a higher heat load on the air dryer. Moisture and oil in the air goes through the dryer. Entire moisture in the, on the oil, it goes through the dryer. High velocity or fluctuation in the dryer. Higher velocity across the dryer and fluctuation. The compressor load and unload. During loading, velocity will more, unload, no airflow. So it will be there. Higher energy consumption due to pressure drop. Untreated air sometimes escapes through the air dryer. So it will go and condense in the user points. So how it should be? So there should be two dry air receivers always. There should be one wet receiver and dry receivers. So all compressors should be connected to a header, and to the header to the receiver, and again one more header to the individual dryers, and again in filters in parallel, not in series, in parallel, and to the dry receiver. What are the advantages here? Here you can choose any compressor, any dryer, any filter. Okay. Then most of the heat the compressed air is getting dissipated in the dryer. Moisture is drained in the receiver. Oil also getting trapped in the receiver. So it doesn't get into the air dryer. So load on the air dryer gets reduced. There will be uniform flow across the air dryer. Pressure drop gets reduced. When oil filters are in parallel, the pressure drop is less. You can some filters you can bypass and you can replace in online, where compressor and dryer can run through other filters. So this is the perfect system. In fact, I have been recommending any client to do this piping. Pipe size also should be selected as per the flow. Most of the suppliers, they give flange size as one step lower. For example, any capacity above 250 CFM thing, air piping should be 4-inch up to the air receiver. But whereas most of the suppliers give either say 50 NB or 65 NB. It should be, even if they give 50 or 60, you should put piping as 100 mm up to the air receiver. So that is, this will reduce overall pressure drop across the compressor room. Ideally, within the compressor room, pressure drop should not exceed 0.3. Cross 0.3 kg. Right now, with the old system, sometimes it is more than 1 kg. It reduces pressure drop, reduce heat load at dryers, quality of air improved, flexibility in operation, energy and maintenance cost reduction. Optimizing air pressure. This is not easy, as everybody thinks. You reduce the pressure. Most of the consultant or energy auditors, even people like I don't know, I will not call Terry, say they'll go and ask them to reduce the pressure. Never do that mistake. So end user application is just study. You reduce the pressure at compressor room by 0.1 kg only, not more than that. Check at user end. What is the pressure? If pressure reduces, you increase the set point at the regulator. See, these are all proportional. If air pressure at a compressor is 7, if you set regulator 4.5, if you reduce it to 6.5, it will be 4 here. So what we have to do, while we're reducing there, you have to increase the setting here. So then only you can achieve the result. Otherwise, if you reduce there, straight away 0.5 kg, you will your end users, they'll come to know about a reduction. They'll immediately stop the whole process. So you do carefully. You study each and everything, and step by step, 0.1 kg, 0.1 kg, 0.1 kg. You observe for 1 week. Record all parameters. Then 0.1 kg. Like that, you go to the idle point. I am sure minimum of 0.5 kg you can reduce at any compressor system by studying this. This will give attractive savings. Yeah, I have to run through. No, Madam, up to what time I can have my presentation? Up to what time I can have my presentation, madam? Madam? What is the time limit for me, madam?
Yeah, you can continue for 2 more minutes and then we can go to question answers.
Yeah, I need another 10 minutes maximum. Is it possible?
Okay, no problem, sir. Take
Yes,
it. Yeah, Q&A will be faster in that case.
Yeah. Okay. Another proposal is, see, sometimes you cannot reduce the pressure because some applications require high pressure. Just study the application. What is the quantum of air required? If quantum is less, if it is less than 10 or 15%, you put air booster for that application alone. And that application, the air booster increases the pressure to the required pressure. Overall, you can reduce. Okay, then quickly. Generally, auto drain. Most of the customers, they go for auto drain trap. Here, you can their losses are more. Along with the air, air is also getting drained. So you go for combo auto drain trap. What is combo auto drain trap? It will have 3 type of trap. One, manual drain for periodical checking, whether traps are working or still some once in a day, you can manually open and close. Then float type trap. Float type trap, it will regularly without loss, it will drain. Then timer based trap. Timer based trap is set for once in an hour or once in 2 hours for a few seconds. So this will reduce your overall consumption for the losses. A huge amount of savings can be achieved. Then use of transector nozzle for cleaning applications. So this, so privately I can give because I don't want to waste time here. So wherever cleaning is applicable, you can go for this type of gun and nozzle. It will be costing only 2,500 rupees or so. You will save a lot. You will reduce your consumption by 70%. Here, it is working on Venturi principle. Then there's a lot of clients, they use multiple pressure. Some applications require 3 bar, some applications require 4 bar. But there are for this bar process linked clients like paper plants. So there are compressors available which gives multiple air pressure like centrifugal compressors. From one stage you can take at low pressure 2 bar or 3 bar. At the other stage you can take high bar 5 bar. You have to indicate to the OEMs your requirement. They can supply. This will work as most energy efficient method. So I'll not go through these slides quickly. There are other approaches available. Sequence of compressors. Operate base load compressor without VFD. Operate with the VFD on variable load. Always go for VFD compressor, smaller capacity. Don't go VFD for higher capacity compressors. Even if you want to buy a VFD compressor, go for one standard compressor and small compressor VFD. Higher capacity compressor work for base load, small capacity with variable load. This will save a lot. Investment will be same. Same cost, you will get 2 compressors. And your payback will be less than 6 or 7 months. Replace compressor air with the blowers for some applications where low pressure you can install chilled water based air dryer. Wherever chilled water is available with the sunlight chillers, you can go for chilled water based air dryers. Air dryer, separate air dryer is not required. So things. So then install variable refrigerant volume. There are like VR system dryers available in the market. Then last point, utilize air as stabilizer and compressor load is less. This is under R&D with something. I have done testing. I have an idea, but I'm waiting for the other client to come out because this entire session can be given. We can keep this compressed air as a stabilized energy. So whenever the power is gone, the compressor has need not run on dryer, sorry, generator. So this will come separately. Okay. See, some case studies I wanted to give. See, I'm engaged as a consultant for a new project because with my the intervention and many plan, somebody told one hotel owner 36 crore project. They call me for design level energy conservation. There are already 5 consultants are there: MEP consultant, then a plumbing consultant, electrical consultant, fire pump consultant, like that. 5 consultants already there. They given the proposal. Everything was to be ordered. So this owner just heard from somebody and they just called me. I was on my way to my native place. On the way he put me thing. I just give him 5 minute presentation immediately. Before I reach my native place, I got the order in advance because he understood that I can deliver something to him. What I told him is, sir, your investment I can reduce by 10 to 15%. Your energy bill I can 20% design level. He said, are you joking? Sir, I'm not joking. You check with whoever I record and check with other vendors. So he cross-verified and he gave the order. This is one classic case I'll just show you. This is not a compressor. This is a chiller. Chiller original design was 280 TR. So I calculated only 200 TR is sufficient. So straight away investment has come down. So again 200 TR, there are 5 suppliers. So all have given various parameters as may required. So I compared. Normally they give some value IPLV, NPLV and all. IPLV, you can go to what is the IPLV, you can cross check. Only those figures they will give. High cost for other thing, NPLV. So the NPLV efficiency ratio totally different. IPLV is for international things. NPL is for our constant temperature, condensing temperature. So this value I plugged in to the my calculation. So I computed the ratings. So operating cost for each supplier I rated. And for 7 years of operation, one chiller will consume 4.65 crores. Other chiller will consume 5.65. Straight away 1 crore. So whereas the 5.65 Wala was preferred make, he was about to order on this make because he has given investment. Investment is same almost 90, 82 or something. He was preferred make 90 Wala. When my ranking of total, when I subtotaled all AMC, everything cost, I have put a ranking and given to him. It was changed upside down. His ownership cost has changed totally. So it almost 1 crore reduction in 7 years. He will be saving. In 7 years, that means every year 10 to 15 lakh rupees he will save. Like that, each and every equipment I studied, I had given to them, and they are absolutely happy. I have to reduce the transformer from 100 kilowatt, sorry, 1000 kVA to 630 kVA. Straight away, bus bar, everything has gone down. So, I'm happy. I mean, I will not get extra pay, whatever I have done it. But I'm happy that I saved for the country, saved for the universe. This is the thing. And one more presentation, last presentation, I'll show you. See, being a lead auditor, I built my home at my native place. Instantly, this building is the highest individually rated building in Asia, individually. if, by putting all the marks, I can be called highest rated. So in my native place, next to my house, if you see tiled house, that was my old house. By adjacent, I put a new house. I put extra roof on the normal roof, where I put wind ventilators. Fantastic ventilators, 4 numbers I put. That will draw air from the house, and it will keep the house up, cool always. We'll get fresh air always. It's a free power. Okay. This wind ventilator I put. Then I have not used any wood actually. It's all UPVC windows. Only main door. That to recycle the wood I am using. Thing. Then solar power, hot water. Then geothermal cooling. One of the rooms I am doing geothermal cooling. It is taking out cooling from ground and cool the room with only 120 watts, 60 watts pump, 60 watts fan unit. Then rainwater harvesting. Landscape I have done over my septic tank and dual flushing taps, low water consuming taps everywhere. I put light tubes, solar light tubes. I'm getting even if you close all my windows, doors with the curtain, I'll get daylight inside the solar light tubes. Then I put glass bricks on the walls at all required places. These glass tubes allows light. You cannot see or you cannot break. You can break the normal brick, glass bricks you cannot break, but it will give light. I'm getting daylight free, daylight even if I close entire house. I'm thinking. Then solar hot water, then solar panel. So like that, I have done my house, and I'm recovering entire air conditioned water also. When the channelized to my bathroom, not a drop of water will go out. So this is how I work actually. So I complete this presentation in time, dot 4 o'clock, madam. Thank you for the opportunity. I am available for any question.
Thank you so much, sir. It was very interesting session, and like many new insights from your session. And so now let's quickly move on to the question answers. So actually, Mr. Levent wanted to see slide number 10 and 11. So do you have any question, Mr. Levent? I will. Yeah, please go to slide 10 and 11. And he has some question about it.
Ten and 11 is thing, not the madam. There's a duplicate. Okay. Yeah.
Mr. Levin.
11. Yeah. See, okay, this I have not covered. Yeah, the implementation in the plant, mostly they are preoccupied with normal operation, and always approach is the best. Our system is the best system, like that approach. Unable to convince the operational production team, inexperienced in implementation, unable to create awareness to the other employees, and establish. Sometimes we will save, but we cannot establish the savings. For example, in a factory, if you replace one incandescent lamp with LED, there will be savings. You cannot show it in the meter like that. Many other those things, individual application only you have to. Then sustaining savings also a challenge. So these are challenges available for energy conservation. Yeah. Any question? Tell me.
Yeah. I think now the next question is from Mr. Anish. Very interesting question. Is BLDC screw compressor available with any brand in India? If available, roughly what is the kW per CFM?
See, there are with the BLDC motor, almost all makes they have. With variable frequency drive, BLDC motor also, permanent magnet motors they have, mostly centrifugal compressors. The specific power consumption they are giving as low as 0.38 or 0.35 also for centrifugal compressors. Whereas screw compressors they give up to 0.45 or something. It is available.
I hope that answers your question, Anish. And now his next question is, will loading and unloading occur in VFD operated screw compressor? And is there any specific reason for that?
Loading, can you repeat the madam? Loading?
Yeah, will loading and unloading occur in VFD operated screw compressor? And is there any specific reason for that?
Yeah, correct. See, sometimes VFD compressors, they would have locked the speed, minimum maximum speed. So the speed reduces to the lowest set point. Some suppliers gives up to 5%. Some suppliers gives only 25%. So there you have to check. If below this prescribed limit, if speed comes, it will unload naturally or stop.
Okay. Yeah. Yeah, Anish, I hope your question you are clear. Or if you have any doubt, you may speak. I am allowing you to talk.
Hello, sir. Good evening, sir. Can you hear me, sir?
Yeah.
Sir. Myself, Anish, I'm basically be accredited energy auditor. So we are doing energy audits in various sectors like steel, plastic, rubber, paper. So different sectors we are doing. So here compressor is a very common utility which comes in most of except buildings. So here actually the first question I asked regarding the BLDC screw compressor. Nowadays a lot of people are using old screw compressors. So we are finding some technology so that to upgrade it to a better specific power consumption. Mostly the best figure I have measured for screw compressor is 0.17 kilowatt per CFM. Just like you
wanted for compressor, I wanted for chiller. Okay.
Yes. Screw compressor, mostly the best figure which we have found out is 0.17 till this audits we have completed till today. So if we replace it with, I have heard somewhere like BLDC screw compressor is available with brands like Kaiser, Atlas Copco, these two brands. So whether, as you told, PMM, that permanent magnet or BLDC, then I want to know which is better and what is the best figure which we can recommend. So that's what my doubt is.
See, typically for higher capacity, more than 55 kilowatt, the motor efficiency is more than 94-95%. Okay.
Yes, sir. Yes.
Yeah. So we may save only just 5%. The benefit of BLDC or permanent magnet motor, whatever I studied, Ingersoll Rand has been giving this permanent magnet motor. They were not able to establish the savings actually. Whereas we can achieve much more than this 3 or 5%. Much more by reducing pressure or optimizing other things. Here savings will be maximum. The possible is 3 or 4% only. Even loss are less. 99% efficiency motor we cannot achieve. There we can achieve 3 or 4% only. But still they are not yet to establish actually. They are giving, but they are yet to establish. As you said, 0.1716. Yeah, some cases recently I've seen they have given 0.15, but they are not given a proof. I mean, we wanted to check actually whether at what pressure again matters. Your 0.16 is at what pressure? What is the operating pressure?
Mostly, I have measured it was operating at 6.5 bar. 6.5.
6.5, they can achieve 0.15 also.
Yes.
Normal standard temperature pressure is 7. At 7, if the people are quoting even 0.15 also, new compressors they are quoting now. I've seen some tenders they have quoted.
Okay. And in sir, one more doubt in that if the temperature, the exhaust temperature, mostly the compressor sometimes they place in a very closed room. So the temperature somewhere the Bureau of Energy Efficiency tells that the temperature reduces in the room. For every 1 degree reduction, there is a 3% savings. So is it correct, or if you do that thing?
Yeah, I also started initially. I told you, if you cool the room, every 3% rise in temperature, 1% energy lose. Not every 1 degree, 3%. It's not
Yes,
true.
yes, sorry, sir. It's vice versa. Yes, correct.
Yeah. So most of the, I mean, suppliers, they are routing the hot air outside the room. Actually, you can channelize the hot air outside the room, or you can. That's what I percent. No, you put an extra heat exchanger outside. Go for water cooled compressor. You
Yeah,
can
that
retrofit.
thing actually.
Yeah.
Yeah.
Take the heat outside. That's
Yes.
the ideal thing. Yeah.
Yes, yes. And sir, the second question, just finishing my query. This VFD operated compressor, you told that they may be locked the speed. So what we would suggest in some cases, even though client has installed VFD to optimize the loading and get the savings, they are not getting the savings. Sometimes the unloading occurs and the power consumed in the unloading region. So whether we should recommend them to change the speed settings, is it the correct way so that unloading will not occur properly?
Maybe the requirement fluctuations more. See, they have chosen the wrong compressor. That's why I told don't go for VFD for higher capacity compressors. See,
Okay.
had they installed one higher capacity base load and small, for example, recently in an American company, I'm just doing auditing. They have 800 CFM compressor, 4 numbers, and 100 CFM compressor, 1 number. So 2 VFD, one normal compressor, whatever you say is happening now. So what I told them is, you just don't run 2 compressors, you run 100 CFM compressor and one 800. So 100 CFM compressor without VFD will run full load. Automatically the VFD compressor load will reduce instead of running 2 VFD compressors. So either they have to go for base load compressor without VFD and one small VFD compressor. Otherwise, there will be loss. VFD itself will consume 3 to 5% power. They are not using VFD actually.
Okay, sir. Okay. Thank you, sir. It was a very interesting session and insightful. So, thank you, sir.
Welcome.
Sir, I like to have one question, sir. This is Giridhar. Ma'am? Hello? Hello? Hello?
So I can hear you. Tell me, sir.
Sir, you are telling about very nice presentation, sir. Thank you so much. Sir, you are telling about connecting dryers in parallel and the compressors in parallel by changing the pipeline.
Yes.
In that case,
Yes,
you are fixing main pressure as 7.5 bar, and then our subdivisions are 4.5 or something. Only one is having 6.5 out of the tabs. Then can you reduce the 7.5 to 6 or 6.5?
Exactly. By studying at user and comfort, you can definitely reduce.
Because this only contributes the power consumption, no? Ultimately.
Exactly. You have to study in total and reduce the step by step.
Because every 0.1 kg we have savings will be there. That is why. Okay, sir. Otherwise, you are
exactly. You cannot reduce at this stage 0.5 kg. You have to check 0.1 kg, then observe for a week. Then again, next 0.1 kg, observe all application. Then it will be successful. Otherwise, if you reduce at a stage 0.5, people will object. You may not save.
Okay. Further, the booster is only for higher side, sir, 6.5 kg or something. Or you can
some applications, because if you study in overall consumption, some 10% of the consumption may be for high pressure. So instead of running a compressor for entire compressor for that pressure, you put dedicated booster and the overall pressure you reduce. Booster can boost up to 2 times. For the particular application. So it consumes some energy, but net you will be saving.
Oh, thank you, sir. Thank you so much. Excellent, sir. Excellent, sir.
Any other question, madam?
Yeah. So for further questions, you can get in touch with Mr. Baskaran. Already email ID is shared, and recording of this session will be available on our YouTube channel, AEE Western India. And if you have any further questions, you can get in touch with us at email address is aeewesternindia@gmail.com. So if those who are looking for memberships can also contact, so that we can help you in becoming the member of AEE. Yeah. Thank you, Mr. Baskaran, once again for the wonderful session, and look forward to future association also.
Sure.
For joining.
Slots available for HVAC, maybe not this month, next month, anything. For HVAC, I'm willing to do it. HVAC is a good subject. There's a huge potential available. I can do HVAC.
Yes.
Anybody interested in
Definitely.
HVAC?
Yes, we will definitely consider. Yeah. Okay. Thank you. Thank you so much. Thanks everyone for joining. See you in the next session.